Good morning student. Today we are going to discuss mechanism of organic reaction. In organic molecule, the bond between the atoms is broken by two types. First type is homolytic fission, second type is heterolytic fission. So we are going to see what is meant by homolytic fission first. Fission in which covalent bond break in such a way that each fragment carries one unpaired electron is called homolytic fission. So just see homolytic fission of chlorine. When chlorine in the presence of ultraviolet radiation or when chlorine is heated, its grade break in an even fashion. That is, this bond break in such a way that each chlorine got one electron. Homolysis leads to the formation of very reactive species called free radical. Now we are going to see heterolytic fission. Uneven breaking of covalent bond is called heterolytic fission. In heterolytic fission, the covalent bond breaks in such a way that the pair of electrons stay on more electronegative atom. So let's consider a molecule AB. In the first case, A is more electronegative than B. So what happens when this bond is break up? The electron pair get on electronegative atom, that is A. That's why A got negative charge, B got positive charge. If B is more electronegative than A, then electron pair is shifted on B. So B got negative charge, A got positive charge. So in this case, B is more electronegative than A. In above case, A is more electronegative than B. So just see this example. We know that bromine is more electronegative than carbon. So when this bond is break up, so it cannot be break up in even fashion because bromine is more electronegative than carbon. So when this bond is break up, bromine got negative charge and carbon got positive charge. Also see that in an acetaldehyde, when we add a base, so this carbon got negative charge while hydrogen got a positive charge. So it is uneven breaking of a bond in presence of base. So now we are going to see what is meant by nucleophiles and electrophiles. A nucleophile reagent is a reagent with an atom which is electron rich, that is having an unshared or lone pair of electron. Such a reagent is in a search of point where it can share these electrons to form a bond. Nucleophiles are of two types. First is neutral nucleophile, second one is negative nucleophiles. Neutral nucleophiles carry lone pair of electron, for example ammonia, water, alcohol molecules. Negative nucleophiles carry negative charge, for example OH minus, halide minus, RO minus, CN minus. Now we are going to discuss what is meant by electrophiles. An electrophile is a reagent containing electron deficient atom. Such a species have a tendency to attach themselves to the center of high electron density. There are two types of electrophiles. First type is neutral electrophile, second type is positive electrophile. So what is neutral electrophiles? These electrophiles don't carry any net charge. Lewis acids like aluminum chloride, FeCl3, Bf3 belongs to this category of the electrophile. Sulfonium ion, that is SO3, carries no net charge but it acts as electrophile for sulfonation in a benzene ring. This is because of its structure. So just see the structure of sulfonium ion. So in a sulfonium ion, this oxygen carry negative charge, this oxygen also carry negative charge, and your sulfur carry 2 positive charge. So basically 2 negative, 2 positive, so net charge on this electrophile is 0. That's why it is known as neutral electrophile. As a positive charge is concentrated and negative charge is scattered, it acts as electrophile. Substance like SnCl4, which have vacant d orbitals, would like to accommodate electron in them. Thus, such a substance also acts as a electrophile. Now we are going to see what is meant by positive electrophile. These electrophiles carry net positive charge. For example, H plus, H3O plus, NO2 plus and Cl plus. So just see, this is the table of nucleophile. It is the table for electrophile. Nucleophile is divided into two types: neutral electrophiles, negatively charged electrophile. Example of neutral nucleophile is ammonia, alcohol molecule, R3N, RNH2, that is basically amine molecule. Example of negatively charged nucleophiles are Cn minus, OH minus, RO minus and halide minus. Electrophiles are classified into two types: neutral electrophiles. Example is Lewis acids, that is AlCl3, Bf3, SO3, HNO3, SnCl4. Second type of electrophiles are positively charged electrophile. Examples is hydronium ion, NO2 plus, Cl plus, ammonium plus. Now we are going to see types of organic reaction. Organic reactions are classified into following types, that is substitution reaction, addition reaction, elimination reaction and rearrangement reaction. Now we are going to discuss what is meant by substitution reaction. A substitution reaction is one in which part of one molecule is replaced by other atom or group without causing change in the rest of the molecule. For example, just see this reaction. Methane is reacted with chlorine and we got methyl chloride and HCl. Now just see here, during this reaction one of the hydrogen is replaced by simply chlorine. So it is substitution reaction. Just see second reaction, that is ethyl bromide is reacted with KOH. In this reaction, bromine is replaced by OH. Just see the third reaction, when benzene is reacted with chlorine in presence of FeCl3, we got chlorobenzene and HCl. So in a benzene, here is hydrogen, each carbon carry one hydrogen. So one can simply say that this hydrogen is substituted by chlorine atom. In a first reaction, mechanism is of free radical type. In a second reaction, it is a nucleophilic reaction. nucleophilic substitution reaction. Third reaction is electrophilic substitution reaction. The substitution reaction may be brought about free radical, nucleophilic or electrophilic reagent. Now, second type is addition reaction. When two molecules of same or different substance combine together, giving rise to a new product, it is called addition reaction. Addition reaction could be brought about by free radical, electrophilic or nucleophilic reagent. For example, just see this reaction in which ethylene is reacted with bromine radical and we got new free radical. So this product is addition product which is unstable. In second case, same ethylene is reacted with bromine and both bromine add across a double bond. So it is a addition product. So this reaction is of addition type. In a next reaction, acid aldehyde is reacted with HCl and we got acid aldehyde cyanohydride. So it is also a type of addition reaction. Third type is elimination reaction. This reaction involves the removal of atom or group from a molecule to form new compound containing multiple bonds. It is important. Dehydrohalogenation of alkyl halide is a common example of this type of reaction. So just see N-propyl chloride. This is the formula for N-propyl chloride. When reacted with alcohol, when reacted with potassium hydroxide in a presence of alcohol, we got propene. So in this reaction, Cl goes away and one of the hydrogen from your N-propyl chloride is also go away to form a double bond. So these types of reactions are known as elimination reaction. Next type is rearrangement reaction. Rearrangement reaction involves the migration of atom or a group from one atom to other within the same molecule. It is interesting to note that the first organic compound, that is urea, is synthesized in Wöhler, actually involving rearrangement reaction. So just see the formula NH4CnO. When this compound is heated, it gives us urea. If we write molecular formula for both the compound, so it is the same. So in this case, only a rearrangement is taking place. Now just see the formula for malic acid. When malic acid is heated, we got fumaric acid. These two compounds are basically isomers of each other. But just see the position of COOH, that is this group, in your malic acid and in your fumaric acid. In malic acid, it is on a right hand side. In fumaric acid, it is on left hand side. So it is just shifting of COH group due to the heating. That is, it is simply a rearrangement reaction. So in our next class, we are going to discuss energy consideration of reaction and some other important concept related to mechanism of organic reaction. Thank you very much.